Hello friends, welcome to my new video. It is the introduction to ion-ion carbide equilibrium diagram. As I said in my last video that I will be posting my new video for introduction to ion-ion carbide equilibrium diagram. So here it is. Let's get started. So basically, first of all, have a look at this diagram. You are very familiar about it now. Now the first of all, the point is the various phases in FEFEC diagram. So the first phase is the liquid phase. It is the liquid solution of carbon in iron. Here you can see this liquid area. Wait, I will show it by marker. So basically this is your region of the liquid carbon. Here carbon is in the liquid form. Okay. The next phase is the delta ferrite phase. It is the solid solution of carbon in iron. It is soft and ductile phase. Since it is soft and ductile, it can be cold worked without cracking. Maximum concentration of carbon in delta ferrite phase is 0.09% at 1493 degrees Celsius. 1493 degrees Celsius is the temperature of peritectic transformation. Crystal structure of delta ferrite is body-centered cubic structure. So this is your delta ferrite region. So this is your delta ferrite region existing between 1539 and 1400 degrees Celsius. The third one is the austenite phase, that is the gamma phase. It is the interstitial solid solution of carbon in gamma ion. It has high solubility of carbon up to 2% at 1147 degrees Celsius. It does not exist below 727 degrees Celsius and maximum carbon content at this temperature is 0.8. But have a look at this line. Actually, austenite does exist below 727 degrees Celsius, but it is in very less quantity. That is means very less quantity. So this austenite which exists below 727 degrees Celsius is called as retained austenite. So it has FCC structure, face-centered cubic structure. It is soft, ductile, malleable, and non-magnetic in phase. So this is your austenite phase. As you can see here, the gamma symbol is there. This represents, the colored figure represents here the austenite region. Okay. Now the next phase is the alpha ferrite phase. It is the solid solution of carbon in alpha ion. It has low solubility of carbon, about 0.025% at 727 degrees Celsius. It exists at room temperature. It has body-centered cubic structure. It is soft and ductile phase, so can be cold worked without cracking. This is your alpha ferrite region. The dotted line here is representing that alpha ferrite is existing up to room temperature. Okay, the colored region is the alpha ferrite region. Now, the next phase is the cementite phase, that is the Fe3C. It is the intermetallic compound of iron and carbon. It is called intermetallic because there is high percentage of carbon in this phase, and due to this there is a metallic structure formed in iron. It has high carbon content of about 6.67%. It has a complex orthorhombic crystal structure having 12 iron atoms and 4 carbon atoms in a unit cell. It is hard and brittle phase. Okay, this is your cementite phase. Existing above the 1147 degrees Celsius, but it is in the combined form, that is the liquid carbon plus Fe3C. So the yellow colored region is the cementite phase. The next phase is the Ledeburite. It consists of eutectic mixture of austenite and cementite. That means Ledeburite is a mixture of austenite and cementite. Ledeburite is observed in cast irons containing 4.3% carbon. Now we will see the Ledeburite region. So this whole is a Ledeburite region. Actually, Ledeburite is in the combined form with other elements like austenite, cementite, etc. etc. No etc. There are only two phases here, the austenite and cementite, and the combined form of austenite and cementite is called as Ledeburite. Okay, now this is your Ledeburite region. So the next phase is the transformed Ledeburite. It consists of perlite and cementite. So transformed Ledeburite is a mixture of perlite and cementite. Perlite. Perlite is alpha ferrite plus cementite. And cementite is, as you all know, Fe3C. So this is the region of transformed Ledeburite. Okay, so this is the region of transformed Ledeburite. It is a mixture of the cementite and perlite. Now we are over with the various phases in FE-FEC diagram. Now we will look to the transformation reactions in FE-FEC diagram. Okay. So the first reaction or the transformation is the Peritectic Transformation. In this reaction, the solid 1 with liquid transforms to solid 2. Reaction takes place at constant temperature 1493 degrees Celsius. The actual reaction which takes place is delta ferrite plus liquid carbon changes to austenite. Delta ferrite has 0.1% carbon, liquid carbon has 0.55% carbon, and austenite phase has 0.18% carbon. Now have a look at the figure of peritectic transformation. So this is the 1539 1400 degrees Celsius points, and this point is say tells us 0.1% carbon, this point 0.18% carbon, and this point represents 0.55% carbon. So So the combined form of delta plus liquid changes to austenite. So this is the point where austenite phase begins, and this is called as peritectic transformation. It has 0.18% carbon. Okay, now the next transformation is the eutectoid one. In this reaction, solid 1 transforms to solid 2 plus solid 3. Reaction takes place at constant temperature of 727 degrees Celsius. The actual reaction which takes place is the gamma transforms to a-Ferrite plus cementite. Both of these can be called, with the combined form, can be called as perlite. Alpha plus Fe3C. Gamma is 0.8% carbon, containing 0.8% carbon here. Alpha is containing 0.025% carbon here, and Fe3C is containing 6.67% carbon. Have a look at the figure of eutectoid transformation. So this line is the 727 degrees Celsius temperature line. That is the recrystallization temperature line. So here is the alpha phase, and here is the gamma phase, and here is the cementite phase. Eutectoid reaction takes place at 0.8% carbon, which comes under steels. That is 0 to 2% carbon represents steel. Now the third one is the eutectic transformation. In this reaction, liquid transforms to solid 1 plus solid 2. That is, there are two solids emerging from the liquid phase. Reaction occurs at 1147 degrees Celsius and 4.3% carbon. The actual reaction which takes place is liquid gives gamma plus cementite phase. Liquid has 4.3% carbon here, the austenite phase has 2% carbon here, and the cementite phase has 6.67% of carbon here. Have a look at the figure of eutectic transformation. So this is the point of eutectic reaction. The portion about this point is the liquid phase of carbon. This is the liquid plus gamma phase. This is the liquid plus cementite phase. The reaction occurs at 4.3% carbon. From 2% carbon to 6.67% carbon, there is existence of cast iron, and this reaction occurs at 1147 degrees Celsius temperature line. This portion consists Ledeburite plus cementite, and this portion consists Ledeburite plus perlite, and this is the line where Ledeburite exists. That is the 4.3% carbon line. Okay. Now we have ended with the transformation reactions in FeFeC diagram. Now we will see the critical temperature lines. So critical temperature lines, there are 1, 2, 3, 4, 5. 5 temperature lines. The A0 temperature line. This temperature line lies in the bottom section of iron-iron carbide diagram, that is the 210 degrees Celsius temperature line. Here, cementite changes from ferromagnetic to paramagnetic in nature. The A1 temperature line. It is the lower critical temperature. Here, at 727 degrees Celsius temperature, austenite to perlite eutectoid transformation takes place. The A2 temperature line. This indicates Curie temperature, that is 768 degrees Celsius, below which a-Ferrite is ferromagnetic in nature. The A3 temperature line. This indicates upper critical temperature, below which ferrite starts to form from austenite. The ACM temperature line. This indicates upper critical temperature, below which cementite starts to form from austenite. So you can have a look at this. Okay, well, take a screenshot and you might read it in the future. So that's it from this video. Thanks for watching. Have a nice day. Bye.